So in part one of the video series, we're going to look at what the central limit theorem is, and we'll demonstrate it graphically in Python. So what the central limit theory states is that if we have a population with a certain mean, then as the sample size increases, the sample mean of this population will more and more closely resemble a normal distribution. So let's take a look at what it looks like graphically. First of all, we're going to head over to Python, and I've already imported NumPy as well as Plotly so that we can actually make our plots. I've also created our random number generator using this seed, which I use random numbers for. So the first thing we're going to do is we're going to make two variables, which nr, I'll set that 10, and I'll set nc to 10 as well. Basically what I'm doing here is I'm determining the number of rows and columns of my data. Once I have that, let's actually generate our random data. So I'll call it data equals rng.random with nr, nc. So basically what this will do is it'll make me an array of 10 by 10 with random numbers to fill in those spaces. So let's take a look at what that data looks like. Yep, there we go. So now what I want to do is calculate the averages, because that's what central limit theorem deals with, averages. What I'm going to do is I'll take the average of every single one of these arrays and make our actual data out of it. So let's call it avg equals np.average. I want to get the average out of the data, and I will do that by axis equals 1, which means I'll do it by row. So let's take a look at what our average data looks like. There we go. Now we have 10 data points. Now that we have that, I'd like to draw a histogram out of it. So in order to draw a histogram, I'll need the actual values and their frequencies. So the way to do that easily using NumPy is that I'm just going to set frequency, value, which is x. I'll set that to np.histogram, and I want to make a histogram out of our average, avg, and let's say I want 100 of maximum number of bins. Once we've got that, we can start plotting our actual data. So let's set fig as make underscore subplots. And then I'll fig.add underscore bar, since a histogram is a bar graph. Our x value should just be our x variable, and our y value should be our f, or frequency variable. Final little touch-ups, I'll just update the layout, fig.update underscore layout. I will set the width to 600, height to 600 as well, and I will use a template, the template plotly underscore dark. So let's take a look at what our data looks like. So yeah, nothing remarkable here. Everything seems to have the same amount of frequency, which is 1. So we have 1 of all of these values, like 0, 1.4, 0.45, and all that. So central limit theory says that as our data gets bigger, it should more closely resemble a normal distribution. So let's increase the size of our data. So I'm going to increase the row number from 10 to 1,000. So let's see what difference that makes. Okay, immediately we're kind of starting to see a bell curve, but it's still not a normal distribution. So let's make it even larger. So I'll add 2 more zeros to the end. Yeah, this is very close to a normal distribution. Let's try adding 1 more 0. And there we go. This is pretty much spot on to a normal distribution. So yeah, this is the central limit theorem.